This video is going to talk about initial value problems, which are simply problems which we are required to integrate in order to find an antiderivative, but we're given an initial condition which allows us to solve for c. Okay, make sure you understand that, or that you get that in your notes and can ask in class tomorrow. But it is important to recognize what it is we're doing before we start doing it. So let's take a look at an example. Imagine that dy dx equaled 2x. And then we were asked to find an antiderivative. Well, that would mean we would be solving this integral. And when we did, we would get x squared plus c. But if we were given that the initial condition, say y of 3 equaled 5, then I could use this given information in order to solve for c in the antiderivative. And here's how I would do it. We would say that since y equals x squared plus c, I can now substitute in and say that 5 equals 3 squared plus c. So therefore 5 equals 9 plus c, or c equals -4. Knowing that allows me to solve the initial value problem with the exact antiderivative y equals x squared minus 4. That is the antiderivative that solves the integral and also passes through the point 5, 3. Okay, let's take another example, and this time pause the video so that you can solve it. Suppose you were given that dy dx equals cosine x, and you were given the initial condition that y of pi equals -2. Can you give me an exact antiderivative? Pause the video and try it. Okay, just as before, this requires us to solve the integral cosine x in order to find the antiderivative. And when we do that, of course we know that is sine x plus c. Now I'm going to use the initial condition here to solve for c. Since y equals sine x plus c, I will now plug in -2 for y equals the sine of pi plus c. Now we know that the sine of pi equals 0, so -2 equals 0 plus c, so c equals -2. Now we're not quite done because we have to put it back in the context of the complete antiderivative. So we have y equals sine of x minus 2. And that is your final answer. Okay, Ramblers, we'll work on some more of these in class. Hope this helped.